Hey y'all, so let's go over 9.3 in the first section we're going to look at now. So the first thing is just making sense of what the complex plane is. It looks just like an x and y coordinate plane, but the x's now are all real numbers, and then the y is the imaginary numbers. So let's graph this first example of z equals square root of 3 minus I. So our real number is the square root of 3. And that would go into the x direction. And the square root of 3 is about in between 1 and 2. And then minus 1 is minus I, and that's really like minus 1i. And so we're going to go down 1 in the I direction. So between 1 and 2, and then down 1. So that point is z equals the square root of 3 minus I. Next, we're going to change... We're going to go from these points to polar form, and we are going to use the equations from before of r equals x squared plus y, the square root of x squared plus y squared, and theta equals the tan inverse of y over x. So let's write those. And we used this before, but now it's going to be like in z. And these formulas are written above as well. So we're going to use z equals the x squared plus y squared, and we're going to use theta equals tan inverse y over x. So here our x is square root 3, and the y is negative 1. So for here, we have z equals the square root of square root 3 squared plus negative 1 squared. After simplifying that, we get that z, or r, equals 2. Next, we have theta equals the tan inverse of negative 1 over square root 3. Plugging that into our calculator, we get theta equals 11 pi over 6. Because if we get this, we end up with tan inverse of, and I'm going to change this negative 1 over square root 3 to be proper, where we don't have that square root in the denominator. So that ends up being negative root 3 over 3 if we multiply top and bottom by the square root of 3. And that equals theta, and that is at 11 pi over 6, looking at our unit circle. And then we just have to put it into the polar form. So z equals r, which is 2, and then cosine theta, which is 11 pi over 6, plus I sine theta, which is 11 pi over 6. And then that's it. Okay. Next, we are going to plot the point z equals 2 cosine theta plus I sine 30 degrees in the complex plane and write in rectangular form. So first we know that r equals 2 and theta equals 30 degrees. So to put this into rectangular form, we're just going to first distribute the 2 to each item in the parentheses. So 2 cosine 30 degrees plus 2 sine 30 degrees I. The cosine of 30 is the square root of 3 over 2. The sine of 30 is 1/2. Don't forget your I. So when you simplify this, we get the square root of 3 plus I. Now let's graph it. So in the all real numbers direction, we're going square root 3, which is about between 1 and 2 again. But now we have plus I, so we're going up 1. And since we're doing this in the complex plane, The R means it has a radius of 2. So we're going to draw 2 circles to show that radius. And you want to make it look the best you can. So that has our radius of 2. And then we're going to draw a dotted line from the origin through our point, because that'll show that this has the radius of the 30 degrees. So that point is the z equals 2 cis 30 degrees. And that's it for this one. Okay, down to, we're going to be using the products and quotients of complex numbers. So we have this z equals 3 cosine 20 plus I sine 20, and w equals 5 cosine 100 I sine 100. So for this first one, here let's label each piece. So this is R1, this is theta 1, this is R2, and then this is going to be theta 2. And so knowing this is how we're going to plug into the 2 equations above. So the first one is our product. So for A, we have z times w, so the product. And so let's just plug in those values to the equation. So R1 times R2, and then cosine theta 1, which is 20, plus theta 2, which is 100, plus I sine 20 plus 100. Simplify, 15, and then cosine 120 plus I sine 120. And that's it for this one. Now doing the division, this is the quotient, and it's z divided by w. So R1 is still z, and R2 is still the w. So 3 divided by 5, and then cosine 20 minus 100 plus I sine 20 minus 100, and that would be 3/5 cosine negative 80 degrees plus I sine negative 80 degrees. But we can't have negative 80. Theta has to be between 0 and 2 pi. Put theta. And so what we want this to be, since it can't be negative 80, we're going to go look at our unit circle. Negative 80 would be about here. So that would be negative 80. So how would we figure out the positive to be all the way around? And that we can get just by doing 360 minus 80 degrees. And we get that that equals 280. So we're going to replace negative 80 with 280. So 3/5, that's not a 3, cosine 280 plus I sine 280. And that's it. Let me know if you have any